See my screen? Hello everyone, my name is Omar ALHEBSHI. I'm a master's student at King Abdulaziz University, Department of Architecture. Today, I would like to present about improving thermal sensation in classrooms with respect to drive avoidance by optimizing the mechanical air supply method. Previous studies showed that young students spend approximately 30% of their lives in the school classrooms. This highlights how classrooms environment can affect both the health and performance or educational performance of the students. The aim of this study is to enhance thermal sensation of the students inside the classrooms by testing and comparing several ventilation strategies for the classrooms. All right. There are actually several factors that can affect thermal sensation. For example, metabolic rate, clothing insulation, air temperature, air velocity, radiant temperature, and air humidity. In this course, this study will be limited only to air temperature and air velocity generated by artificial ventilation system. This study will use Wenger equation to calculate BMV index to evaluate the proposed strategies in the study. There are many factors. As a point of departure, we have carried out a questionnaire for students to evaluate their thermal perception inside their classrooms. Many students showed that they're unsatisfied about thermal conditions in their classrooms, as around 33% of the students said they have a cold perception inside the classroom. Okay. The object of this study is to improve thermal sensation inside the classrooms by optimizing or testing several alternative for ventilation strategies, aiming to enhance thermal perception of the students. Here, the slides show some of the standards that will be used to evaluate thermal perception of the classrooms or the students, such as ASHRAE 55 standard and ISO 7730. Here we have we conducted research as Scopus database for 3 keywords: thermal comfort and classroom thermal comfort and adaptive thermal comfort. As we can see here, only 395 articles about classroom thermal comfort or thermal comfort in classrooms. This shows a lack in articles or research studies in this field, as we can see here in the previous 10 years. Here we have some standards our evaluation will be based on, such as ASHRAE 55 standard and ISO 7730, in addition to some previously carried out research in the similar conditions. Here's the methodology of the study. We'll start by collecting data, then analyzing this data. Then we propose our ventilation strategies that can be used or implemented in the tested classrooms. Previously, we can summarize them in 3 ventilation strategies: mixture ventilation strategy, displacement ventilation strategy, and stratium ventilation strategy. Then we are going to evaluate these strategies and select the best one or the optimal one. Here are selected classrooms to carry out the experiment. 2 selected classrooms in Jeddah city in Saudi Arabia. Here are some pictures from the classrooms and specification for the classrooms. Each one of these classrooms has different orientation, capacity, and number of windows, in addition to area. This slide shows the architectural plans of the classrooms. Classroom A with capacity of 60 students and classroom B with capacity of 45 students. Here is the used measurement to measure the air velocity and air temperature with 3 thermoanemometer with data logger with its specification here. For the first classrooms, we measured out the air temperature and air velocity for each student seat inside the classroom. Here in the highlighted in the light blue is the thermal comfort or thermal comfort zone of ASHRAE 55. As we can notice here, the red points represent the thermal temperature readings. Most of the temperature readings are out of the thermal comfort zone, as we can see here. For the other classroom, at the same time or as the same results of the previous classroom, most of their temperature readings are out of the comfort zone and more further from the comfort zone than the previous one. Before starting carrying out our simulation process, we carried out a grid independent test to select the most appropriate grid quality to complete the simulation process. We tested out three grid qualities: coarse quality, medium quality, and fine quality, with 10 different points at the center of the both classrooms. As the results of grid independent test show, the medium grid quality show the minimum relative error compared to the actual experimental results. So we selected the medium grid quality to complement the simulation process. We started out by simulating the current conditions of both classrooms. Here are the configuration of the inlet and outlets of the air supply inside the classroom A. To save the time, we will jump to the results. The result of the simulation with the correct condition of the first classroom showed that 80% of the temperature readings are below the comfort zone of ALHEBSHI 55. Here is the correct condition. Here is in blue is the comfort zone of ALHEBSHI 55. It's out of the comfort zone. Sorry. Classroom B, the configuration of inlets and outlets in the classroom, and the results of the simulation of the current condition. We can say that 96% of the air temperature readings are out of the comfort zone. So the current condition is totally out of the comfort zone of ALHEBSHI 55, as shown here in the psychometric chart. Here are the proposed ventilation strategies to be implemented in the classrooms. First one is the mixing ventilation strategy with both or with two other configuration or other arrangements of inlets and outlets inside the classroom. The second one is the displacement ventilation and the stratum ventilation strategy. Here is the first scenario, the mixing ventilation and the configuration of the inlets and outlets. Here, this diagram represents the displacement ventilation, and this is the stratum ventilation. The results of the study showed that, as we can see here, this can show it more clearly. These are the, first, this in the blue color or green color represents the comfort zone of ALHEBSHI 55. The current condition of both classrooms A and B is totally out of the comfort zone, as we can see here. The stratum ventilation and displacement ventilation showed the most neutral values of BMV index, as we can see here. We can conclude the results of this study in 3 points. First one, the distribution of the air temperature and air velocity in using the currently installed ventilation strategy is not stable and differ or variant in different places in the classroom. The second point is the current condition of the both classrooms are not satisfied or not comply with ALHEBSHI 55 requirements. The third result is that we can improve thermal sensation in the classrooms by using displacement ventilation and stratum ventilation by significant BMV values than the currently installed one. That's all. I'd like to thank you for your attention. I'd be happy to answer a question you may have.
Thank you very much, Mr. Omar. And before I ask any question, I would like again to go to our audience. If there is any question from our audience.
Yes, I have a question, please.
Yes, please.
So, Mr. Omar, the only difference between the DV system and the stratum was the location of the supply duct, isn't it?
Between what or what?
The location of the supply of the air.
Which systems are you comparing?
The DV system, displacement ventilation, and the stratum. I have worked on the DV system in my master's thesis, and I know that it's different from the conventional system is that you supply air at the floor level, right?
Yeah.
Yeah, so the stratum system, what's the difference between the DV and the stratum system? I have noticed from your figures just the location of the inlet air.
Yeah, it is. Here, I mean by stratum ventilation, that I fixed the air inlets and the at elevation of 1.8 meter at the wall, as I see it from previously done research. Displacement ventilation, I supply the air from.
How is the stratum ventilation better than the displacement ventilation? Because displacement ventilation depends on the buoyancy forces to move the air inside the space, right?
Yeah, as the buoyancy level is not equal in both strategies, the BMV value will vary between the two systems. I here adopted
so what
a BMV.
system was better in providing comfort to occupants, the stratum or the DV?
As my results show, stratum ventilation is slightly better than the stratum.
Yeah.
Yeah.
Yes.
Slightly,
Okay,
not.
Okay, thank you very much. Just one more question, please. How did you control the inlet temperature and the velocity of the air?
It's fixed, as this slide shows.
Are they the ambient conditions? They were the ambient conditions? I
fixed the air velocity at 2 meters per second and air temperature at 24 in all systems. It's an option in the CFD. I use ANSYS Fluent CFD process.
Yes.
You have an idea about
so
that.
You didn't conduct an experiment, right? It was CFD simulation.
I conducted an experiment to validate the results.
Yes. So how did you control the inlet temperature and the velocity in the experiment? In the experiment,
actually, I don't have that much control. I use thermostat to control
okay. So you use the ambient conditions.
Yeah.
Right. Okay. Thank you very much. That's a very interesting topic. Yeah.
Thank you.
Thank you very much. Thank you.
Is there any other question?
No, thank you.
Thank you very much, Mr. Omar. Really appreciate your presentations.